everything's working. And I even have mic this time. How nice is that? I got music. I got all the things that I'm supposed to have. Okay, so for people... Oh, it says I'm streaming higher than the recommended bitrate. How rude of me to do that. Can I change that live? Is that just going to straight drop the bitrate? Yeah, okay, it looks like it did. Perfect. Okay, YouTube was telling me that my bitrate is too high, so I've now fixed that. So those of you with terrible crummy internet connections can now watch me. So, start by way of explanation, I developed this guy a couple of weeks back before I bought my new license. It is designed to sit on the front of a printer, which I now realize I don't have a handy model of. So I'll just bring that up real quick. Oh, hang on. That's not even right. So, right now, I'm trying to find... Here we go. Top level solid as it, not solid part. I'm done. I have an existing model of my printer, and my objective was... yeah, I know it's educational. It's because it's before I had the license. Shut up, SolidWorks. My objective with designing this... No, not that one. This one. With designing this particular pie enclosure, I don't know why that's decided to be transparent. It's very rude of it. Is to sit up here on kind of the corner of the machine. Problem is, my machine's way bigger than an Ender 3 Pro. If you pull up an image of an Ender 3 Pro, you will see that this distance right here is quite short. Like, this bed is 200 millimeters long. Just open this like a new tab, and there's not very many good side views, but you can see this distance right here is quite short, and I was not planning and basically didn't account for what on my printer is plenty of clearance between the front of the head and the back of this enclosure. That distance is negative 20 millimeters. It's way too small. So my objective here is to... wow. Is to sneeze, apparently. That right there keeps this guy constrained fore and aft. I'm going to basically hang it off the front. I'm going to design a bracket that'll sit right here on an equivalent space on an Ender 3 Pro. We can go pull up an image of that. On this one, it's got two fasteners right here. I'm going to basically design a bracket to sit right here and let me move the whole component forward. So, yeah, let's get started. I have an existing part that was a previous design for a holder that didn't work very well. It was kind of, it doesn't put the pie in a very convenient location. You can see that it basically just hangs the pie out in space. Not really great. So this time around, kind of have to figure out what I want this base boss to look like, and then I'll come up with a top boss to provide a cover for the bottom section, and also a capture point for this little, I think that's an M4 right there. Let's take a look at the part. In the part context, this is a 4.5 millimeter diameter hole. So it probably even says that. Yeah, M4 clearance holes in the center of those two mounting bosses. So I already have a part file open, so we'll just get to work. I think first step is going to be this sort of front, like deciding what I want this front to look like. I have to come up with some points to define where I want my holes and some circles around them. Let's make these two guys equal. And this is going to be 40 mils across. I guess I should clarify that I do know some existing dimensions already. Like if I go and look at, oh, where is it? This guy. If we come up to this first extrusion here. Oh, I guess the first extrusion was actually this rather than the base plate. What made this surface? It's a move face for some reason. This guy right here. So this was what I had originally, and you can see that it's 40 millimeters vertically and it's 40 millimeters horizontally, and that's what I have to use as the sort of the defining characteristics for that structure. So this guy, line all this up. We're gonna make some holes to space everything here, space everything nicely. I think these two are already equal. They are, okay. This guy's gonna be 20 mils. This guy's gonna be 45. And then we'll do a quick 20 millimeters between the two of them. And now we have all of our points, all of our critical points defined, so we can start shaping our geometry around that. These guys can be tangent to this and this, which locks those in place. And this line, rather than defining an angle, I'll tell it to be tangent to these two circles. So, in case I wanted to do like, that actually just isn't that helpful, but if I wanted to change this angle, say, actually it might break if I change this angle. Yeah, so it broke a little bit, but you can see how less extreme changes would let me adjust where everything is functionally. So we're going to go ahead and change it back to 45. And I have my points in place, which is perfect. Yeah, that looks good enough. Let's call that maybe, just like reviewing from the upper right here, let's make this like 5 mils thick. Probably even a little thicker than it needs to be. If I go and look at this one, this guy, 4.5 millimeters thick, so normal. That seems like I thought that was good enough then, so I'm going to consider it good enough now. Let's do extruded boss. We're going to go from the top plane rather than selecting the face to make sure I don't over-constrain anything. And then I'm just going to make it, I think this can just be a quick rectangle because I want to make sure that I cover up the bottom of the enclosure with this bracket so that I don't leave any open holes into the cavity. Not really necessary, but a nice, sort of a best practices sort of thing. And so here's where I have to do a little guesswork, but not really. I don't know necessarily, I'll call that like 30 mils. I don't know necessarily how far off the front of the printer this has to be. Except, I asked my little brother, who is with my dad, or who's staying with my dad at the moment, to tell me how far off the front of the printer it had to be in order to not hit the print head on my dad's printer. So, I don't have CAD to verify it, but I have a number that says 30 millimeters away, you're probably good. Which is just fine for me. Looks like, how big is that chamfer? 2 millimeters, okay. So that means I'll have to, if I want to stylistically match it, I'll have to add a little 5 millimeter chamfer out of the end there, but that's no big deal. So let's come back here and make a quick circle. Whoops. By the way, this context menu right here is super handy. It's built into SolidWorks right-click context. You can right-click and then drag to access a whole bunch of things. I don't use it for a whole bunch. I mostly use it for lines, circles, and trim, but oh, and dimensions as well. But that's because I learned using it with only those 4, and when I realized I could turn it up to 12, I did. I just haven't gotten around to building that into my mental workflow yet, really. Oops, that's 20 millimeter diameter, because that's how wide the pad is. I'll go ahead and go verify that in a sec, but get this geometry in to start. Whoops. Where'd my point go? Cannot place a user point on top of an existing point. Bite me. I want to put a point there. You don't let me. It seems to be a new feature of 2020. It won't let you put points in the middle of circles unless you put the circle on top of the point, then it's just fine, but I don't know, man. Actually, if I make a circle and I create a point over here and I tell it to be coincident, oh, I can't have points. Yeah, that's bizarre. I think it's a bug. I think I need to send in a service request about it, but it's not super important yet. So we'll just make this guy 5mm thick's probably fine. It could cause a little bit of issue maybe with interference on these faces when I cut those holes, but that is a bridge that I will drive a car across when I come to it. What is I looking at? Oh yeah, so the reasoning for that 10mm, back in this sketch, to place a point here, or 20mm rather, that diameter, is to match it up with this hole, which is on a... does it not have? Whoops. Here we go. 10mm radius, so this is a 20mm diameter circle that sits into the corner of the part and lets me define where that hole is. So, let's do a quick hole wizard. I'm gonna make these, oh, I don't know. These are gonna be M... Oh no, I don't know that they're gonna be M4. They have to match whatever this is. Those are M5s. Glad I checked. Oh wow, 3 people watching. Hi 3 people. So let's go ahead and do, let's see, I think it was hole wizard. M5. We'll start with a button head cap screw, or a socket button head cap screw, and that'll give me the right dimensions for all this stuff. And then I can just cut this dimension down as I need to. So now I'm on my face. I know where I want my holes. What I'm going to do is I'm going to visualize this sketch and convert entities. Nope, that didn't work. Let's convert those two. And that gives me 2 points that are exactly where I want them. I don't have to think about it, they're just there. So I'll drop those in. There's a little bit of silliness happening there. You can see that it goes behind that surface. I will fix that, just not yet, I think. I have to kind of figure out how I want to do that. How deep did it make those anyway? It said 2.75, which it's kind of done. Yep, down there. In the measure window too, it'll tell you 2.75. This down here, super handy, having a quick way to visualize your dimensions without having to open the measure window, select your faces, can really, really speed up dimensional checking if you're worried about placement of that sort of thing. As I recall, this part, which also already exists and is on the printer, oh hey, check that out. It fits just fine, and it looks like I didn't change dimensions either, so I'm going to go ahead and leave that. I'm not going to tweak it. It's fine as it is. But what I will do is I will do a quick extruded cut. This is kind of a hacky thing, but we're going to pick those two up, make them co-radial. And then this circle is going to make an extruded cut in the other direction. Up to next, draft. I think that wants to be, let's see, like 15 degrees. And then we have a nice little cutout there. Nothing really important, just nice tiny spot to make it nice and clean. What next? Let's do, oh, I forgot I need a hole up here too. Features, hole wizard. Wow, 4 people watching. Hi, 4 people. Did I remember to enable live chat? I feel like I'm worried because I always feel like I forget that. Yeah, I've got live chat. If you have any questions, ask. I'm always happy to answer. Let's see. This, I think, is going to be just a regular screw clearance hole, and I will show you why in just a sec. Up to next, M4 position. Whoops. I don't want to create my own point for that. I want to... hang on. Let me see my dang sketch, please. Okay. Let me see my sketch. Let me do a hole wizard. Let me pick this face. Neat trick. You always have 2 views over here, so you can look at your feature tree even as you're working in a property manager for a feature. So we're going to go ahead and pick this surface, and then visualize. Oh, that sketch is already visualized. Convert entities from the sketch, and so if I move that point around, as long as I don't delete it, the reference won't disappear, and I'll be able to move that point around later. It's super handy in like big hole patterns. Not really important here because this is so small, but handy every once in a while. Especially if you're changing hole patterns a lot like I do, because I'm dumb. But yeah, that looks alright. Now, for my next trick, I have to Google the dimensions of an M4 nut, because I can never remember what they are. Okay, 7 across flats, 3.2 thickness. I'm just going to do 3, because that's fine. We will do a quick extruded cut on this surface. Control 6 to come to the bottom. And mouse over the circle you want to be concentric with. And then you can make this hexagon, which is going to be a captured nut pocket, basically. Concentric to your existing hole. So, wow, only 18 minutes. This stuff always... It feels like it took less than 18 minutes, I guess is what I should say. So we're going to make that nominal at like 7, maybe 7 point... 7. That's fine, because I'm going to make it drafted as well. Favorite trick in the whole world. Offset your depth, and then you can move into the part, flip your direction, and then you can draft outward just a little bit to make things neat. And then you'll have your nominal dimension at the bottom of the hole, even though you were modeling at the surface. You don't have to make an extra plane to model from. And you get just exactly your geometry only where you want it, which is fine the first time. You don't have to think about it too hard. Okay. That's actually most of the geometry that this part needs to have, so I'm just going to start adding fillets now. Well, I should rename things first, actually. Whoops. So we've got base extrude. I call this the tab extrude. Not the extrude. And this is the M5 two-frame counterbore. This is 5 head clearance cut. It's so little material, but if and when I publish this model, I'll go with if, because I'm not really sure this is something anyone will ever really need. It's stuff like that goes from, yeah, this is a pretty good part, to this is a nice part that somebody cared about. That's my real peak objective here. So we have M4 to enclosure hole. Or we'll just call it to enclosure. Actually, let's add. Yeah, that's fine. And then this is the M4 hex nut pocket cut. That is really all of our main features. So, time for fillets. Nope, no it's not. I forgot. Important. I need to add a rib, which is tricky. I don't know how I'm going to do it, because it's going to get kind of screwy. Let's go... Let's do a sketch on this plane. And I'm going to do a... This is going to look extra weird. I'm going to make this point coincident with this plane so that I know that it's perpendicular there. I'm going to make this guy come out to, say, 15 mils. Let's do 10 mils, actually. And then I want this guy to be 20 mils. So then I'm dead on center line right there. This is going to look really silly, I think. I'm worried about. Let's just not worry about it. Let's just wing it. How am I gonna even... I don't know how I'm gonna make that shape work. what I have in my head is, turn my music down on my end a little bit. I want it to be a little bit swoopy, but I don't want to overshadow this hole and make it hard to put a fastener into, because then that's just bad usability. If you can't get a fastener into it, it's not useful. And I just realized I made that too sharp because that would obstruct a tool getting down there. Make sure you can get tools to your fasteners, otherwise you're boned. So let's... oh, goodness. Oh, it's going to be all sorts of fiddly. What if I just didn't do that? What if I just made it... what if I just put the rib in the middle and didn't think about this as hard as I'm trying to think about this? Sketch on the right plane, and I just did kind of something like this. Yeah, that's fine. Let's just do that. That's a lot less difficult to think about. And 10 millimeters is way too thick, so let's do 5 millimeters is fine. The rest of the structure is 5 millimeters too, so that won't make anyone angry. There we go. Now we gotta gust it. It's not gonna be fussy or break or anything. Let's do chamfers. Those were 2 millimeters, I think, on my other component that I'm trying to match the bottom of. So I'll add those guys. Do I want to add a chamfer up there? You know what? Nah, it's fine without it. Let's do fillets. I'm going to do 1 millimeter on these guys first. And then I'm going to do, say, like 3 millimeters on the rest of these. Oops, why are we not cooperating now? Is it not like having 3 millimeter fillets up there? What about 2 millimeters? Maybe I didn't like that. Yeah, that works. Oh, hang on. I bet I don't have keep surface. Keep surface far and away a preferable tool, I think. Oh, is that even going to matter? I might have to revise where that cut is taken. Or when that cut is taken. Yeah, it just breaks when I do 3 millimeters. Oh, it's probably because right there. That makes sense. And now that's all sorts of jacked up. Whoops. Let's move this guy. Nope. Oh, no, that's the counterbore. I want the head clearance cut. Let's move that down there. What's it look like before that cut? Oh, that's gross. Oof. Can I leave it like that? If I don't have that cut there. I really don't like that. It just looks gross. What we're going to do instead is... normally I try to keep my chamfers and fillets to the end to try and prevent silliness, and in the past I used to draw a lot of my features relative to existing edges on the part, and that's not really great practice. It tends to make things screwier than they should be a lot of the time, especially if you want to change that fillet later down the road. Your features might move back and forth, which is super not good. So instead what I'm going to do is I'm going to use an even more gross feature, a move face. See if I can't grab that face from down here. And we're going to move it up to... I'm just not going to worry too much about being precise with it. I'm just a B, tell it to be 2 millimeters. It breaks. Whoops. Okay. Time to be even more gross. Pick that sketch plane. That works. And then we get our little cutout there, and our fillet's all nice. It's not actually nice, but it's nice enough. This is, I think, really all that this needs to be. So we'll go ahead and save that in projects file is Rudio Proyecta extension bracket, and then we will come back and take a look at this guy. Ask him what happens if we drop this extension bracket under him. So we'll line those up. Looks good to me. Concentric, don't lock rotation though. Pick our two faces so that they sit together. And then just pick this face because that's fine for lining everything up. That all looks good to me. I bet if we come and look at that on the full-size model. So the thing that I care about now is I know this hole is going to be 10 millimeters off from the side because it's running into these holes that run down the center of the T-slot. So I know that lines up. I know I'm good on that part. The next is just where else could I possibly want chamfers? The answer is everywhere, of course, but I should probably show some restraint in that department. But broadly speaking, that looks pretty good. I think I'm going to take... Yeah, we're going to add some more exterior chamfers just for nicety's sake. Chamfer. Make it 2 millimeters like everything else is. Whoops. Does it really break on those fillets? It does. That's not great. So we're going to remove this first fillet here. We're going to... Hang on. Missing a fillet in there. That's weird. Oh, it was probably relying on those fillets to complete itself, but now it's all good. Now all our fillets are in the right place. We go before the move face and the chamfer op, though. So that's such a minor cleanup feature that it really should stay till the end. So now that's busted. Let's select tangency because that saves me a lot of clicking. Whoa, that's busted. What's going on there? Oh, that's weird. It's picking up on the nearby edges and it's like making them extra long for some reason. Oh, that's awful. All I want for Christmas is some uniform chamfer functionality. Whoops, cut that off too soon. Just let me put chamfers on things. Tangency, tangency. Yeah. How's that look? Grossly over chamfer, just the way I like it. What happens if I put a chamfer up here? I bet this will break everything. Yeah, it doesn't like that. If I get rid of these two, chamfer there. Yeah, I think it's just... It's going to have those chamfers, and that's fine. Makes this part a little weird, but... Actually, hang on. No, I don't have to be weird. Not necessarily. Come on. I haven't even selected any of those... Oh, wait. I have kind of selected some of those edges. Does not like not having those edges selected, does it? Okay, I'm going to use the cheapskate method. I'm going to let those be selected for now. And they are symmetrical, which is nice. I'm just going to go back to the rib, and I'm going to say, you are now going to be 2 millimeters inside of this line. And that will prevent the rib from doing anything silly. I hope. Or prevent the fillets from doing anything silly. Let's actually remove the midpoint constraint on that one too, and tell it to be, say, like 10 millimeters from the bottom. Yeah, I think we'll still clear there. Actually, maybe we won't, so I'm going to leave it at 15. Yeah, that's what we're looking for. So now I can come back up to this existing fillet operation and add that guy right there. And then we have chamfers everywhere we want them to. We got fillets everywhere we want them to be. Part looks fine. Doesn't make me want to gouge my own eyes out. Yeah. And it matches the existing sort of stylistic chamfer every available edge look that I was going for. Let's quickly... Oh, I didn't have these faces on here. Yeah. Yeah, I don't think I have anything else to add to this, so that's what it looks like. Or rather will look like on a much smaller printer. Let's see if I can't line those up so they at least meet up nice. Oops. Nope, don't preview, please. Very rude of that to be right there. We're going to make that face with this face, and that'll move the whole thing to the right a little. And it'll all line up. That, I think, is probably good enough to stop fiddling with. Yeah, I don't have anything else. I'm probably going to cut the stream here shortly, but again, if you have any questions, fire them away in the comments. I'm always happy to answer. Yeah. Tiny bracket design. Tiny, grossly overcomplicated bracket design. Best kind. Looks good in situ. Yeah. Very nice. Alright, well, actually don't save the top level. I don't want to keep that pie assembly in there. It's fine to be in this one, just because, but now that I have a proper license, I'm trying to keep my pre-license and my EAA license stuff and I have my own actual license stuff separate. This one gets to be an exception because this is what this bracket's intended for. So we'll just shrink all that up. Let's do a little bit of last feature naming. Reinforcement rib. Chamfer A. Fillet A. And chamfer B. What was this move face for? Oh yeah, it was the M5 head clearance base move. And that's the M5 clearance cut. Yeah. Alright. If you liked it, like it. If you didn't, dislike it. I'm not going to tell you what to do. Thank you for coming and watching. Have a nice night. Boink.